time series analysis is a vast topic, so we do not discuss each and every details of it, but the idea here is to get started you with the how to use the time series analysis in R. Okay, so we have this data set called air passenger, which is available within R. We'll just run this line. Now the name of this data set is very long, so I'm trying to create the shortcut by using the name AP. So AP is my data frame where I have all the observations that are there in the data set air passenger. Let's see what is the structure of this data set. So you can find that there are total 144 values, and the years are running from 1949 to 1961, whereas there are values of each month because we have years, so there are total 12 months in a year, and this indicates the number of passengers travel in each month of each year. Let's see the first few observations of this data set. Okay, so this shows the number of passengers travel through the year in each month of the year 1949 to 1954. Well, now we can have the function called time series analysis, and we can specify the data set AP to this function. The frequency is set to 12 because we have 12 months in a year, and the year starts with the 1949 and the first month of the year is January. That's why we have specified this value 1. Okay, and you can see this data. Okay, so this is the year, and these are the number of travelers, number of passengers traveled in a month of January. These are the number of passengers traveled in month of February, which is slightly increased, and so on. Okay, so let's see what are the attributes of this data set. Okay, so this value 12.00, this indicates that because we have 12 months in a year, so it indicates the month. Thus this value 1949.00, it is the starting value of the year, and this 1960.917, this value, this is actually the last value of your data set, which clearly indicates that the years are running from 1949 to the end of 1960. So this 1960.917, this value is basically, it is the average of all the months in that year. Okay, so let's create a plot for this data set. Now this is a plot. I'll just zoom it for the better interpretation. Now here this graph, it clearly indicates that there is a increasing amount of travelers over the period of years from 1949 to the 1960. There is also there is some amount of seasonality. You can find it here. These are the some amount of seasonality shown in each year. Now in each year there is a period of time which is higher, and in each year there is a period of time which is on the lower side. Now one thing that we can notice here is the span in the initial of the time series. For example, the span in the span in this initial time series, it is very smaller, and it is increased towards the end of this time series analysis. So the span at the end of this time series analysis, it is increased. So now this could create a problem that this can make your time series analysis or your time series chart a non-stationary. Okay, so we can solve this problem by doing the log transform. So we can add the log transform to our data set. So we can do so by using this log function. So log in the data set is specified. So this will create a log for our data set. So the points are the log are created for the every data points in your data set. So let us now plot the data set, and now if you compare this time series with the previous time series analysis, you can see that or you can easily observe that the span is not much fluctuated as compared with the previous time series. Okay. Now let's decompose this additive time series by using the function called decompose. To this function we have specified the data set called AP, and we are going to store this decompose additive time series into a object called as decompose. Okay. Now let's see what are the figures of this decompose using this feature called figure. So these are the figures of the decompose time series. So this is for the first month, that is January. This is for the fifth month called May. This is for the ninth month, September, and so on. So we can have this decompose figure for each month in a year, okay, for all the years. Now I will try to create the plot for this decomposed figure values. For this, all these figures, we'll create a plot. So decompose figure, comma, I will add some features, that is type is B, the label of the x-axis is month, the label of the y-axis is seasonality index, whereas the color of the lines, that I want to ensure that the color of the graph, color of the lines would be blue, and we are ensuring that the numeric values to be appear vertically. So let's run this. I'll just zoom it. Now here each point indicates the month, so we can have January, February, March, April, and so on up to December. Now here it is interesting to observe that this July, August, this June, July, August, September, these four values, they are quite high as compared to the average value, average seasonality index. So this indicates that, but particularly in fact, the values of this July and August, they are having 20% more volume as compared to this other months. And the other interesting part is about the November. In the month of November, which is 20% on the lower side. And the rest of the months, if we talk about this March, April, and May, they are very close to the average. Okay, so because we have created a log of our data points, so each data points, they are now stationary, and we can see that this July and August, these data points, they are having 20% more volume than other. We can see this easily. So let us create a decomposition plot for these figures. So this is the decomposition of additive time series. So the first decomposition, it is that we have observed, it is basically our original time series that we have seen in the previous part. The first decomposition component of this additive time series analysis is the trend, which clearly shows that there is a increase in the number of passengers over the period of years. So this is clearly indicated by this trend component. Then we can also have the seasonality within the year for all the years in this time series analysis. So it is indicated by this seasonality decomposition component, and then we have the random decomposition component. So this clearly shows that we have the three different decomposition component of our additive time series analysis. Thanks a lot. In the next video, we are going to see the time series analysis for forecasting. Thank you.